Hey guys, Violet here. I'm going to go over derivatives in this video and help you realize that it's not as complicated as it seems. And I'm not going to jump into the definition of a derivative and like exactly what the formula is and how you use it, because all that's going to do is just overwhelm you and possibly confuse you. So what I'm going to do is talk about what derivatives are. And I'm going to use a graph to introduce what they are, but I'm not going to continue using it as I continue to explain, if that makes sense. So I'm going to start by, let's say you have this function here. And you want to know exactly what the slope is at this point right here. And so, well, how would you find that? And so we're going to find out, as you zoom in closer and closer, you're going to find out the point on there. Now why is this even useful? What is it all about? Well, derivatives can help you tell how the function is changing at any given point in time. And so by looking at a very, very small portion of the graph of a function, you can determine what is it going to do. You can predict what will happen to the function. What is its behavior at a very, 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 very infinitely small point. And that's why limits were so important, because we're using the concept of limits as a basis for derivatives. We are going to see, as we approach the limit of a very, 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 very small window on this function, as this box gets smaller and smaller around the function, we're going to define what the slope is of that function at that point, in the, as our teacher calls it, the neighborhood of the function. So let me go now and talk about a tangent line. And it sounds kind of weird. It's like, I'm going off on a tangent, but I'm sorry with the dad jokes again. But the thing is, a tangent line is basically a line that touches the graph of a function at only one point. And I'm gonna attempt to draw it here. Let's say you have this point right here on the graph, and the line is going through. I said I wasn't going to use the graph to explain. I'm sorry, I was mistaken. I'm kind of I have a list of what I want to talk about on here, but I'm kind of improvising a little bit to make it flow better. So this line, if you were to zoom in super, super close to that line is going to tell you what the slope is of that function at that point. Now, how do we know that? Well, let's consider something. So let's say you have another function right here, and it's curving like that. And you want to find out, actually, let me draw another function here. This one's not curved enough for my example. So we have a function like that. And you want to know what the slope is at this point. Actually, that's a bad point. But the slope is at this point. So you could say, well, how would I figure that out? Well, you can take a point over here and a point over here and draw a line between them and get the slope of that line, because that's kind of close, right? It's not exactly the same, but it's pretty close. And that would give you, if these points were equally distanced from this, that would give you an average of the slope of between this point and that point, an average of what this slope might be. But that's not going to be exactly the same. And this kind of line is what we call a secant line. It intersects the graph at two points, only 2 points, at least in the area you're looking at. Because this function could go woo, woo, and it might intersect again, but we don't care about that right now. We're looking at this part of the function. So anyway, the slope of the secant line is very important because we're going to use that to find the slope of the tangent line in a little bit. So let me explain. So one way you could think of a tangent line is as this secant line gets closer and closer, you're going to get a better and better average. So let's see, you have this function. I'm going to draw the same function again, and instead of, that's our main point, instead of it being this right here and right here, we're going to go from right here and right here, and as you can see, that's a lot thinner than the other one, and that's going to give you a much more accurate slope for this, what the function's doing right at that point. But it's not exactly perfect, and it doesn't exactly describe what the function is doing at that point. It's a good approximation, but it's not an actual value, and it's not going to help you to know. So how we relate this to the tangent line is this. I'm going to draw the same function, and there's our point. And once that line gets closer, so okay, it's referring back to this, as this line gets closer and closer to that point, we're going to get a better and better average of, it goes like that. You're going to get a better and better average of the slope. But once you hit that point, once it becomes closer and closer and closer to the point that it actually touches it, that's your tangent line. So I didn't draw that function good. Let's try it again. So the tangent line would look something like that. And I know that's a very bad representation, but just know this line intersects that point, but doesn't intersect the graph at any other point. And so that's our tangent line, and the slope of that line is gonna be the behavior of that function at that point. But how do you find the slope of that line? Because it's not gonna give you, it's gonna be very hard to know exactly what the slope of this line. So let's say we want to find the derivative of this point, the slope of the tangent line at this point. Well, it's gonna be entirely different. And so you need to find an expression that's gonna work for you no matter where you are on the graph. And that's exactly what a derivative is it's a function that tells you the slope of the tangent line at any point in the graph. And this can be useful for finding the behavior of that function. So going back to this example over here, as you take the tangent line, let's say of this point, goes up like, that's a very bad drawing, sorry. Let's go on the other side. The tangent line at this point is right there, and the tangent line at this point is right there, and the tangent line at this point is right there. So you can see how it's changing, and the slope of the line continues changing. So at any point, you're going to want to be able to say, how is the function behaving at any point on the graph? It doesn't matter where on the graph, you're going to find out what the slope of that point in the graph is. Okay, so now let me go back to limits. Actually, I think this video is long enough. I'm going to stop it so that it's easier to upload.